Hello and welcome back to another episode of Math with Stone. Today we are going to be talking about 4 different types of graphs. Before we get into that, I need to go over a simple vocab word called univariate, which sounds intense, but uni indicates single and variate indicates variation. So that would be one thing that you're looking at. Okay, so one specific thing that could be what is your favorite color or how old are you? And you could have, if it's univariate, you could survey all the boys and that would be one variable or one variation. But if you had a bivariate, then you would survey the boys and the girls and maybe you would separate them. Okay? So, univariate is data measures one characteristic of a population, not two. And these are the 4 main, not the 4 only, but the 4 main ways that you could do it. We're going to talk about the easy ones first. You have a histogram, which looks like a bar graph. And the difference between a histogram and a bar graph is that it shows intervals more often than one specific thing. So like here to here would represent probably 145 to 155 type of thing. Okay, so that 145 to 165. Or 150 to 165. Oh my gosh. 145 to 165 type of thing. It'll show you an interval. It won't show you one specific thing. Wish I could count. All right. They also have the bars squished up next to each other because there is no gaps. It's always a continuous line. So this is 0, this might be 30, and then we have 60, and then this would be maybe 70, and so on and so forth. All right, I like it when the histograms actually show the intervals so I know what I'm going and talking about. All right, so that's a histogram. We've done those. We have stem and leaf, which a stem and a leaf, they even gave a key here. If you would start with the number 5 and end with the number 8. So the number 5 with the line here and 8 represents 58. 6 with no leaf does not say, that means 6 with not a 0. That means that there was nothing in the 60s or the 70s or the 80s. So there was no 60 or 61 or 62 or 63 or 64. But there is apparently a 112. So this would have the numbers 58, 112, 124, 135. See how I'm doing that? 112, 124, 135. Then we wouldn't have anything for 14, so I'm not going to put down a 14 and then a 0 because that would mean that we had 140. There would be a 0 here if there was 140. There's not. 152, 152 again, and then 153. So if it's written twice, that means it was there twice. So that's stem and leaf. Stem and leaves have the ability to actually do not just univariate, but bivariate. You could have like a leaf on this other side that could represent something else. So this might be the number of, I don't know, what would be something in the 180s? The number of hamburgers eaten in a year, okay? And then the leaf could be the number of chicken sandwiches. And it could represent 2 different things. All right. A line plot is very similar to a histogram, but each dot represents the exact amount of each thing. So apparently we had one number 60, and we had no 80s, no 90s, 100, and we'll say 110 happened once. And 120 happened once. But then 150 happened 2 times. Okay, so it represents, each dot represents how many times it actually occurred, and you don't have to number each and every thing, but it does show a really good trend if you have a lot of data values, if you really needed to know exactly what was happening. And last but not least is the box plot, often called a box and whisker. The box and whisker by far has the most going on with it. Okay, so we're going to have to slow down for that one because the box and whisker tells you several things. It shows you the smallest value, which we call the min, and the largest value, which we call the max. All right. Now, a line plot would also do that because see how here, that's the smallest value, that's the minimum, and that's the biggest value, that's the maximum. Now, that's all it really tells you. Okay? It can also tell you the mode. I guess you could look and be like, which one's the highest? That's the mode. Here, this one would also tell you the min. That's the min, and that's the max. And the mode would be 152. Mode is, by the way, most frequent. So min is the smallest, max is the biggest, and mode is the most frequent. The one that happens the most. And then if you didn't know the mean while we're doing all these, we got the average. Remember the average? And then the median is not the average, but it is the middle. I don't know when you guys have heard these terms last, but I'm pretty sure you've heard of most of those at some point. Okay? Now, a box and whisker also tells you not the mean, but the median. So this is the very middle value, even though it doesn't look it. This guy right here, 100 and it looks like 151 or 150 is the median, which means that half of the data is above that number and half of the data is below that number. And then these right here, these are quartile 1. They call them quartiles, but I'm just going to call it a Q1 and a Q3. Which means technically the median is Q2, all right? And what that tells you is it actually shows you where the percentage of data is. 25% of the data is in between here and here, which means a lot of people are spread out over there. It shows you the distribution. A lot of people are really far apart in that first quartile. But then most of the people are pretty close together from here to here, because this is also from here to here, from 120 something to the median at 150 something is 25% of people. 25% of people are here and 25% of people are there. So it shows you where the percentage of people are, which has some value, and that's what we're going to be focusing on for today's lesson. Now that we finally got what are the actual graphs are, now we're going to focus on what are they good at, okay? And each one has some specific pros and cons, all right? So a line plot is pretty good if you really need to see each individual detail and how it's shaped. Like you can kind of tell that this guy over here is not, like he's off on his own, but most of the data was right here, spread out. And not only that, but like we only had one repeat number. Everything else had just one value. So there's certain things that the line plot can tell you that the box plot couldn't. We don't know where everybody is. Maybe most people are at like, what if we had like 5 people at 80? We wouldn't have known that. We just know that the 25% looked like they were spread out between 60 and the 121. So we're going to learn about that. We're going to get some things done. So shows the distribution of the data set. So that is the what is it percentage-wise? So all of these, for the most part, can tell you how it's distributed, but maybe not exact percentages. Maybe not exact percentages. If we needed exact percentages, then the only one that would be excluded would be the histogram. So this cannot do exact, but it could get you close. Okay, does it look like 25% of the data, or even more? Does it look like this is around 50% of the data? Yeah. And does it look like these 3 other ones are around the other 50% of the data? Yes. So it looks like about half and half, but we can't get exact. Whereas these, we could get exact, but it would take some time. Okay, so it doesn't really show it, but we could calculate it on the other ones. But the box and whisker, that one's the best. That one's the best at showing the actual distribution. All right? So, data shows the general shape. Well, that would be true for a line graph. And when we're talking about shape, we're actually talking about like, where is it all skewed? Is it in the middle? Is the majority of the data in the middle? Or do we have the majority of the data kind of all off to the one side? So that can happen from a line graph. You can see the dots visually with that. It could happen with a histogram, and it could kind of happen with a stem and leaf. If you kind of turn it, you get a visual of that same sort of shape. Like, see it? That's the shape. Okay. Data is displayed in intervals, also called bins. So that happens, I think, for the most part, exclusively with a histogram, but you could argue the box plot because you could say the interval from 60 to like 121. But I'm going to put this is the best, and this is kind of like a maybe. Line plot, no, not really. And stem and leaf, not really. Those are pretty much every number. All right. So I would also argue that this is best and this is best. And this is pretty good. That one's pretty good. And this one is not really, but almost for that one. All right. Displays each individual data. Well, that one is pretty obvious that it is only going to be a line and it is only going to be a stem and leaf because the histogram has intervals and we don't really have many data points at all for the box and whisker or the box plot. Displays a 5-number summary of the data set, and that is only, it is the best and only. These, it could be calculated, and this one could be calculated, and this one is no, not. All right, and what it means by 5-number summary is pretty much these: the min, the max, the mode, the mean, the median. But by definition, 5 is the min, the max, the quartile 1, the quartile 3, and the median, which we talked about before. Okay, so those are by definition what they are. All right. This part right here, we're just going to breeze through real quick. I might end up doing the majority of this entire sheet with you, although I'm probably going to say pause here and then watch the video and see if we agree, because the backside is interpretive. There's not necessarily one right answer. All right, so we're going over a review. Categorical or numerical? Well, favorite colors are categorical. Numerical, the other day we talked about them as quantitative, which bothered me because I always was trying to say qualitative, which is actually categorical. So how many people are in your family? Numerical, you can have 1, 2, or 3. How old are you? That's a number. How tall are you? That is a number. What is your favorite sport? That's a category. You could either like basketball, football, or something weird like badminton. My wife just looked at me and she is judging me for saying badminton because apparently badminton is not weird. A watermelon, apple, or a pear looks like the categories of fruit. And we were supposed to put possible responses. I guess I did badminton there, but I don't know how to spell badminton. So, how tall are you? 6 foot 0 inches. That's how tall I am. All right, flipping it over. So we're going to do the top 2 together right now. Then I'm going to have your teacher pause this video, or you can just do it along with me, but I would recommend trying some of these on your own. So, Basil records the weights rounded to the nearest pound of 15 dogs at a pet show. So that is quite a few weights here. Explain and which one would be better, a line plot or a stem and leaf plot? So line plot or stem and leaf. We only got 15 dogs to show here. Personally, I think that the line plot is going to be best. Okay, we are not required to do these, but here's why I think it would be best. If we went 7 all the way up to 163, so we could count by, I don't know, we could say that this is 0 and this is 175, and then somewhere in the middle would be like 80, yada yada, and then we could plot these individually, and they would be able to be plotted, and we could see the general shape and where it was at. And we could also see that there was a few data points that were kind of showing where the clusters of it were, and then we'd have big gaps in between 100. We would have 100 right here, and then we'd have like 1, 2 more dots. So you would be able to see that the majority of pets are kind of not that heavy. And then there's just a few off to the right. But you could argue that the stem and leaf would also do that, and that the stem and leaf would be better. So the line plot shows you where they're clustered, but the stem and leaf would show you that there are 2 in the 60s, which might be beneficial to you, and that there is 2 dogs that are in the 10-pound range. Okay, and then there are 2 dogs in the 70-pound range. So I'm almost changing my mind, but I think that the stem and leaf is just a little bit less than what I would want. All right, the other reason that I said stem and leaf is just a little bit less than what I want is because for part B, now we're recording cats too. So if we were recording cats, which display would be better now? A line plot or a histogram? Well, both would be okay, but I would personally pick, let's just say histogram. I'm going to show you how to do both, but I'm not actually going to do them fully. So the reason that I would pick histogram is I could do dogs over here, and then I could do cats underneath if I wanted to. That would be one option where we would have a few dogs that are from 0 to 10. And we could do the number of dogs, and we could say 0 to 20 pounds, and then we could say 20 to 30. And then we would have from 0 to 20 for dogs, we would have, how many do we have for dogs? We got 4 dogs that are, 3 dogs that are from 0 to 20. So we would put 3 here, and we'd go up to 3 for 0 to 20. And we don't have to color it in. And then how many cats are from 0 to 20? And here's the dilemma, though. All the cats are from 0 to 20. We would be stuck here like that. That'd be silly, wouldn't it? Okay? But it is possible. We would maybe have to scale it differently. What if we did a line graph instead? What would change? Well, we could use the same graph that we had before, but we could put dogs up top. We could put cats down low, and then you could just number the cats to visually see that those would be down there. So I originally said histogram, and I might be changing my answer because all of my cats fell in the 0 to 20 range, and that was kind of silly. The other option that you could do is, sometimes I've seen it, but this works more with bar graphs. This is more of a bar graph. You could do dogs here, and then you could have cats in like a different color right next to it. So this could be dogs, and that could be cats, but I don't normally see histograms doing side-by-sides like that. I've seen it a few times, but not really. So this is a bar graph, which was originally what I was thinking of when I picked histogram, but I might be changing my answer. I'm going to go line plot because we would be able to get all the cats visible right underneath just like we had here. Okay, let's do the next one. We got, oh, wait a minute. He updates his data to show the nearest weights to the nearest tenth. Ooh, explain which display would be better for the data, a line plot or a histogram. Well, now I'm doing it to the nearest tenth. I really don't want to do a line graph with 4.1 and 4.3. And even if I did, how would I know that it was 4.1? I am upgrading for sure to histogram because maybe if I just did cats, we'd have the number of cats here. And we would have from 0 to, let's do 4 pounds. Actually, we'll do 0 to 5. We would have 2 cats. And then from 5 to, what would it be, 5 to 10. How many cats do we have from 5 to 10? 1, 2, 3, 4, 5, 6, 7. So we'd have to go up to 7. And that would show us that, decimals are apparent, but maybe line plots wouldn't be very good. It wouldn't show us anything with that. If I were doing this one personally, I would probably do neither of these. What I would do more than that, it would be, I think stem and leaf would be best. But the question didn't ask or give me that option. So out of the 2 options, I think I'm going to pick the histogram. But if I had the option for stem and leaf, I would pick that. But out of the line plot or histogram, I think that because we don't want to have to deal with 4.1 on a line plot, that I think that the histogram would be better. Okay? Miss Rowland asked her students, new question, asked her students how many pets they each have, and wants to use a graphical representation that will allow her students to see the overall shape of the data and give them enough information to calculate a 5-number summary. Okay, so we want to know the shape and be able to calculate. Calculate means that we don't want to necessarily see it right away. We need to just be able to calculate it. So if we flip our paper over, in order to get the 5-number display, the box and whisker would be best because we could see them right away. So the box and whisker would tell us the 5-number set right away, but I can't see the shape with that really. And I want to be able to see the shape. So which two could I use to see the shape and be able to calculate? I could use the line plot or the stem and leaf, assuming the line plot shows me individual values. If the line plot doesn't show me individual values, then I'm going to be stuck with stem and leaf. Okay? So I am going to say the stem and leaf is best. Line plot would work. The box plot, the histogram is a big no. Big no. And box plot is also kind of a big no, but maybe without the exclamation point. Because the box plot would tell me the 5-number summary, but it doesn't show the shape. So I am sticking with line and histogram because I can calculate it. I can calculate the 5-number, and I can see the shape of the data. I can see, how many pets they have with it. Okay? And to be honest with you, I honestly think when I'm looking at the question that I even might change my answer. How many pets do you think most people have? Actually, let's do a survey. How many pets do you think most people have? Do you think that they could have 0? I think a lot of people might have 0 pets. Out of a full class. And then I think the majority of people are going to have 1. A lot of people are going to have 1, and each of those dots would represent that. And I think some are going to have 2. A good chunk are going to have 2. And then I think a few less are going to have 3. Maybe like that. And then I think that it's going to jump to like 5 or 10 if we include fish. And we're going to have like 4 people that have fish and they have a bunch of pets. Okay? Could we calculate the mean, median, and mode? Yes. Would it be annoying? Yeah. All right. And that would be our data. And I think that the line plot would probably be best because stem and leaf, we're not going to have a leaf. You can't have a stem of 0 and a leaf of blank because it wouldn't work. All right. So if the number is bigger than bigger than 10, stem and leaf would work better. But I don't think we're going to have enough animals to make that happen. So I'm actually going to take away stem and leaf. Stem and leaf would work if it were something that would be bigger than 10. Like how many hamburgers did you eat last year? The majority of you are going to say more than 10. Okay, you need to do 3 and 4. I encourage you to pause it. I am going to finish them and then explain why in a bit. But I'm going to encourage you to pause this, try these, and then come back and see if you agree with my answer. And I'm just going to keep on rolling in a few seconds so that you have an opportunity to pause it before I say what's going on. So here we got Camilla wants to create a graphical display that represents the types of speeds of 425 students at a school. That is a lot of students. Okay, because it's that many students, I think a box plot would look really good. I think that a histogram would look really good, assuming that the speeds vary by a lot. But I don't think I would like a line plot or a stem and leaf. Okay, the reason why is line plots, you have to plot every data, and I think I'm answering the next question, and that's a lot of dots. That's a lot of dots. And the same thing would be true with stem and leaf. A box plot might be important because we might only care about like the 25% fastest and slowest. And that might be important to us. We might want to know what's the fastest person, what's the slowest person. It would also tell us our min and our max and where the majority of people kind of fit in, which I think that would be the best. So I'm going box plot is the best, but a histogram is also pretty good. Pretty good. All right. Camilla says, making a line plot of this data would take a lot of time and would be hard to make sure that each dot is in the right location on the number line since speed can be given as fractions in seconds. And I would agree with that. And due to the fact that speed can be written as fractions in seconds, that also means that histograms is a pretty good choice. Explain whether you agree or disagree. I would 100% say yes, it's difficult. But I don't know if it's not the best. Okay, just because something is difficult doesn't mean it's not a good way to represent something. All right. But I think that a histogram is almost just as good as the line plot, and therefore would be a better choice if we had to choose between line plot and histogram. Number 4, the last one. Dallas records the highest temperature for each. Which would be the best representative of the data? Well, I do not agree. This is a no-go, and this is a no-go. Do you think that I would care about where the majority of the data is? We don't even have that much data to begin with. So box plots work really best whenever you have a lot of data. They tend to simplify things down. A histogram, we only got maybe 3 ranges. Okay, so like you'd only have from like 70 to 80, 80 to 90, and then 90 to 100. That's not enough separations and categories. Maybe you could do 70 to 75. Stem and leaf would be okay. That would be okay. But I think that the line plot is best. That's my personal opinion. And the reason why is because I want to know how, like, which one's the most common. And, yeah, man, stem and leaf would also be pretty good. Okay, so both of them would be okay. I'm just going to do the line plot as the best. And that would be because I can see the most popular temp, if there is one. There might not be a most popular temp, and I think it's 92. 92 plus 93 would be right there, and 91 would be right around it, so I think that that would be best, personally. Okay, Dallas decides to change his data to include the average weekly high temperature. Explain whether this changes the display he should use. Average data, weekly high. So, let's see. I think that it not really. I think that the stem and leaf would be fine, and the line graph would be fine as well. I need to put a box on the stem and leaf. You could do a stem, and you could have a leaf for the first data, and then you could put the average right next to it. Or you could do the same thing with the line plot. You could do the first one here, and then you could put the average underneath it. But I think the stem and leaf would look a little bit visually prettier. So that would be maybe what I would go with. But I already said stem and leaf would be fine to begin with. Okay. That's it for this one. Until next time, stay positive, my friends, and I will see y'all later. Bye.